All right, so our question is, what percentage of water do you think is available for human use? Um, I see a lot of 73%, some 3%, 12.5, 30%, 60%, 50%. So we're kind of all over the place. Um, we are going to watch a video and it's going to kind of answer some of that for us. Um, It is right here. We're going to watch it and see if it changes some of our viewpoints and perspectives about this. If you want to go ahead and number in your box number 1 and 2, because I need two interesting facts from the video, and you can type them in the box.
Giant 97%. As humans, we're well aware we need water to live. Fortunately for us, we live on a water planet. But that doesn't mean we have an entire globe of H2O to use as we please. So just how does the usable water break down for us? A giant 97% of Earth's water is in the ocean, so we can't use that. 3% is fresh water, but even in that small sliver, about 2% is locked in glaciers, ice caps, and groundwater. That leaves about 1% of the fresh water on Earth that is accessible and usable by humans. Let's imagine all of that accessible fresh water fits into this tiny pool. Now we'll get to some small numbers when we look at global freshwater. There really is a small fraction of usable and accessible freshwater on this water planet, so how do we use that tiny pool? In the United States, about 49% is used in thermoelectric power production, while agricultural irrigation makes up about 31%. 11% goes to public use in our cities and towns, 4% goes into industry and manufacturing, and 1% is domestic use. The water coming out of our faucets largely comes from precipitation. Measuring how much or how little precipitation falls can impact how we live our daily lives. Elsewhere around the globe, in developing countries, agricultural irrigation accounts for about 70% of freshwater use, while industrial use is 20% and 10% for public consumption. In places where access to usable freshwater is greatly limited, knowing when and where precipitation may fall is critical to livelihoods. Precipitation replenishes these tiny reservoirs of fresh water, and data from the Global Precipitation Measurement Mission will help farmers, ranchers, and policymakers in these regions plan for periods of drought, flooding, and other extreme weather.
All right, so in our space, and that is in our box, go ahead and type your answer. What are two interesting facts that you learned from the video? Two interesting facts. right, so what I am seeing. Most of the water we use is for electricity. Only 1% of the water is used for drinking and cleaning. Most fresh water is frozen and in groundwater. Very true. 49% of the Earth's water in the U.S. is used for thermal and electrical uses. Most of the Earth's fresh water is trapped under the ice and in glaciers. Rivers and lakes are very small parts of freshwater. Factories use a lot of fresh water. Yep. 4% is industry, 1% is domestic, and a large percent is precipitation. Okay. Good. So we got some good stuff out of that video. Alrighty. So, um, we are going to go ahead and proceed with our notes. You will need a copy. Looks like this. So if you didn't click it and get a copy, they are in Canvas, and you can get them that way. We're going to go ahead and get started at the top part. All right, so where is all of this water? We just learned that a large majority of the surface of the earth is covered in water. We need to know that hydrosphere is all of the water in our whole planet. Hydro always means water, and sphere usually refers to something that is circular. In this case, it's talking about every bit of water that is on our planet. Most of the water that is in our hydrosphere is in liquid, but just like the video we just watched, some of it can be in ice, which is the solid form, and some of it will be in water vapor, which is our gaseous form. We talked about that yesterday. So here's some facts. That 71% of the Earth's surface is covered in water, just like our bodies. 71% of our bodies are actually made of water as well. There are two major types of water. We have salt water and we have fresh water. Next week, we will go really, really deep into these two different ones. That's all we're going to talk about next week is salt water and fresh water and all the information that goes with them. Today, we're just talking about the breakdown and how it's actually distributed on our planet. So we have a discussion question. Our question says, hypothesize why there is a shortage of water and why people don't have access to clean and fresh water. There is space for you to type this in your Google Doc right here. I suggest that you go ahead and type it there and then copy and paste it into our discussion so we can have that. I'm going to give you about 3 minutes to go ahead and get your thoughts out where they need to be, and then we will talk about it. Got about 30 seconds to wrap up our thoughts. All right, so our time is up. So let's talk about it. Reasons that I am seeing. It depends on the place that they live. Um, a lot of water gets wasted. We waste a lot of clean water. Um, um, because water can have bacteria in it. Um, and people don't always have access to ways to purify water. I like that. Um, it could be because of a drought. They might live in a dry area where water evaporates fast. I like that. Um, because there's little to no rain, and the video said that water from our sink comes from precipitation. So that means if a place doesn't get a lot of rain, they will not be accessible to water. Okay, that's a very interesting viewpoints. So to answer that question, we need to move on to the next slide, and we will talk about that. All right, so with distribution of water on the earth, whoop, oops, with distribution of water on the earth, all of the water, if we have 100% of the water that is on earth, about 97% of that is going to be salt water. This is going to be your oceans. This is going to be your seas. The water is definitely going to be salty, and it has other minerals in it. The freshwater amount is going to be about 3%. It is found in ice, groundwater, aquifers, surface water like lakes and rivers and streams. That's only about 3% of the water that is on Earth is considered fresh. Now, the problem with availability of water is that we as humans cannot process salt water. It will make us dehydrated, and we will have issues from if you drink too much of it, you will vomit. It could also lead to extensive diarrhea, and all kinds of different issues going on. I don't know if you've ever watched this show. It's called Naked and Afraid. It's a really interesting show. It's like a survivalist show, and it deals with these two people that get stuck in the wild. They go to different places. Some places are tropical near beaches. Some people are places are a little kind of chilly and cold. But the people that get put in these remote areas, they are in the nude. But then they also have to figure out how to survive in that environment for sometimes it's 14 days, sometimes it's 21 days, and survive and be successful in that environment. So there have been a few episodes where they were stuck on an island, or they were near salt water, and they had the idea, the places they had freshwater sources, but they had to actually go find the freshwater sources. Some of them were saltwater sources, and they had the idea to boil the water, one, to kill any bacteria or anything that was in the water, but two, to also kind of boil out some of the salt that's in the water, so that way they would be able to drink it. There have been a few episodes where people did not boil the water, and they ended up getting sick and had to get medical attention because, like I said, our bodies are not made to process salt water. So if they did that, they had to like dip out the top of the water that was in the top, let it cool down before they were able to drink it, because the water in the bottom was still kind of infused with that salt. It also doesn't completely get rid of the salt. The only way you can do that is you actually have to treat it and send it through like a water treatment plant, that it is put some chemicals in there, and it does a bunch of other different stuff to separate the salt out, but it doesn't always separate all of the salt out. So for the most part, salt water is not accessible for us to be able to drink, which leads to the shortage of water. So if only 3% of the water that is on the entire planet is accessible for us to be able to drink, we also use it to clean with, to cook with, to do all of these different things. Out of that 3%, only 1% is actually usable by us, because the other 2% is stuck in ice, whether it's in glaciers or it's in polar ice caps. We only have access to 1% of the water that is on the whole planet. So some of those other factors that you named also can play a role. If they're in an area where it's a desert and it doesn't rain a whole lot, they may not be able to get the precipitation that they need. If there's not a source of groundwater where they can tap into, because wells are a tool that is used to tap into groundwaters. Next week, we're going to talk about aquifers in depth, and we're going to talk about how aquifers actually are natural filtration systems that actually filter out a lot of bacteria and contaminants and all the rest of that stuff out of the water, and is actually usable and drinkable by us as humans, and we are able to use it to wash and clean things and all the rest of that. But if we only have access to that 1%. So that is the reason why there is a water shortage, because there's only 1% of all water on the planet that we are able to actually use. Somebody earlier today asked, well, can we use that salt water to do some of our cleaning so that way we can save the fresh water to drink? It is a good idea. However, a lot of our cleaning agents that we use would react completely different in salt water. So they may not clean as well because of the salt content that is in the water. So that could be an issue as well. With our three types of fresh water we have, like we said earlier, a large part of it is ice. It is stuck in polar ice caps. They can be glaciers as well. Surface water is going to be our rivers, our lakes, our streams, ponds, any of those areas that you see on top of the Earth's surface. Groundwater is going to be beneath the Earth's surface. They're usually accessed by wells or through drilling and pumping water out from there. But for the most part, they are stored underground. Rock layers help with the filtration of that water so that it is nice and clean when you are ready to use it. So if we had to put this in perspective, everybody loves money. I love money. Everybody loves money. It's kind of like you having $1,000, but out of that $1,000, you can only spend 30 of it. That's it. The rest of it is held up somewhere and you can't even get to it. Out of that $30, only 21% of it is frozen in the bank. It is considered like our polar ice caps. You can't take it out of the bank. It has to stay there at all times. The other, out of that $9 you have left, $8.70 is buried deep underground. So it's really hard to get to it. You can get to it, but it's really, really hard. So that only leaves you like 30 cents out of that $1,000 that you have access to, that is on the surface, that you can just walk up and get it. So if that puts any perspective to you of how much water that we actually have at our fingertips and access to, it's not a lot. All right. So our last video that we're gonna watch is this Bill Nye video. I love Bill Nye. Bill Nye and Miss Frizzle were like my science people growing up. I love them. But we are gonna watch this video by Bill Nye, and he is going to talk to us about the water cycle. Those 4 questions that you see listed there, we are going to talk about them, and we will be done with our notes for today. So those of you that don't know, y'all know I'm nostalgic. If you've heard that beat before, it came from Crisscross. Make you want to jump. Ask your parents; they'll tell you about it. It's an awesome song. All right, so we are going to go ahead and go over to our document. We should have all of this information filled in, and we are here. If you missed the video, there is a link to it right here, so that way you can click it and watch it. Show it to your parents. They'll love it and be nostalgic right along with you. Well, with me, shall I say. All right, so number 1, does water always stay in the same place? Go ahead and answer that in the chat. No, they do not. Why does water not always stay in one place? Good job, Amarion. Yes, it is because of the water cycle. Water goes through that cycle. There is no end. There is no beginning. It goes through there. It goes through all of the different states that it needs to be in to get through that cycle. So it does not always stay in the same place. Number two, will salt water always be salt water? No, it will not. Why? Yes, Marcus and Zaria, y'all got it. So it is salt water will not always be salt water. It is partially due to the water cycle, because when the water in the water cycle gets evaporated, only the fresh water gets evaporated. All of the minerals and the salt and everything that is in the ocean gets left behind. Um, and so it does not actually get evaporated with the water that goes up to the clouds. When it precipitates back down, it's only fresh water that comes down. It's not salt and salt water. As it rains and comes back down, the water levels will still, reach equilibrium in the ocean because of when it rains down, it'll just fill it back up. So I know some people asked earlier, does that make water saltier if the water gets evaporated out of it? It does, but it doesn't. So, like salinity, it can fluctuate and still be within normal ranges, but it does largely depend on the evaporation rate and kind of the rain load that has happened at that time. But for the most part, it's still kind of equal. The ocean's a very large place, so just because it's evaporating in one place does not necessarily mean that it's evaporating everywhere. So it could be precipitating somewhere else while it is evaporating somewhere else, and waves mix it all together and nutrients and all that good jazz. So for the most part, the salt will be and other minerals will stay in the ocean. Number three, where will there ever be more or less water on Earth than we have today? Good job, Marcus. Oh, Mario, you on it today? You're right. There will be that will not be the case ever, because of this whole water cycle. Water just goes through this same pattern all the time. So there will never be more or less water on Earth than we have today. It just may be in a different part of the cycle, but it won't ever go away. We should remember that from that video we watched earlier this week with Tim and Moby when they were talking to us about water, and they were talking to us about how some of the water we drink may be left water that a prehistoric animal drank out of. I think they used a dinosaur. I think. And number four, our last one. Where does water spend most of its time? Where will we normally find it? Will not, Brandon. Yes, it is found in an ocean. It is usually found in the oceans. That is our largest part of water, body of water. Most of our water will spend most of its time there as it goes through before it goes through the other parts of that cycle. All right, so the last things that we have to do today, we have a water distribution demo. If you click here, there's a video that actually kind of demonstrates this whole breakdown of water. If we were in school, we would have actually done this and probably kind of led with this activity and answered some of these questions as we went through the day. But we're not in school, so we get to watch the video. And when you get finished watching the video, you answer the questions, fill in the parts where it is highlighted in yellow. After you have finished, you're going to submit them to Canvas. We are going to distribution of water is where we are today. You're going to submit them to this assignment and turn it in. Once you are done, you do have a quiz that is available for you. Notice it says it's open for 2 months. I hope it doesn't take us 2 months to take it. You do have 3 attempts to do it. It will average your scores together, so you will get an average of your 3 scores. It would be in your best interest to go ahead and do the best that you can on the first go around, so then you will be good and get the highest score possible. If you are watching this video and you have questions, please send me a message in my Canvas Canvas inbox, and I will answer them as soon as I can.